Multiwire branch circuits are a source of confusion in electrical installations. A frequent error involves the two-pole breakers not being common tripped. This mandates that the handles must be tied together, which requires a special tie bar designed for this purpose. Common tripping ensures that if one pole trips due to an overload or fault, all associated poles trip simultaneously, preventing unbalanced voltages and potential hazards. The absence of a common trip mechanism can lead to a situation where one circuit remains energized while the other is de-energized, potentially creating a dangerous condition for anyone working on the circuit or connected equipment. It's crucial to install the correct type of tie bar that is listed and labeled for the specific breakers being used to ensure proper operation and compliance. Another prevalent mistake is the failure to properly identify the neutral conductor for the multiwire branch circuit. Each hot conductor in a multiwire branch circuit must have its own designated neutral conductor. This ensures that the current from each hot conductor returns on its corresponding neutral, preventing overloading of the neutral conductor. Overloading the neutral can cause overheating, insulation damage, and potentially fire. If a shared neutral is improperly used, the current from multiple hot conductors can combine on a single neutral, exceeding its capacity and creating a hazardous situation. To avoid this, each neutral conductor must be clearly identified and labeled to correspond with its respective hot conductor. This can be achieved through color coding, tagging, or other approved methods. The National Electrical Code, or NEC, contains specific requirements for multiwire branch circuits. Reference NEC Section 210.4, which addresses branch circuits, including multiwire branch circuits, detailing requirements for voltage between conductors, permissible loads, and identification of the neutral conductor. NEC Section 300 covers wiring methods, providing additional guidelines for the installation and support of conductors in multiwire branch circuits. It's important to consult these code sections and any applicable local amendments to ensure that the installation meets all requirements. To further clarify the requirements, consider the following points. Firstly, the voltage between hot conductors in a multiwire branch circuit must not exceed 300 volts to ground in dwelling units, although there are exceptions for specific applications like electric ranges, dryers, and air conditioners. Secondly, the neutral conductor in a multiwire branch circuit must be sized to carry the maximum unbalanced load. This means that the neutral conductor must be large enough to handle the current that would flow if all the hot conductors were loaded to their maximum capacity, but not all loads were operating simultaneously. Thirdly, multiwire branch circuits are permitted to supply more than one device or equipment on the same circuit, provided that all applicable requirements are met, including overcurrent protection and grounding. Fourthly, when installing multiwire branch circuits in metal enclosures, such as metallic conduit or metal boxes, it's essential to ensure that all conductors are grouped together to minimize inductive reactance and voltage drop. This can be achieved by using cable ties or other approved methods to bundle the conductors together. Fifthly, the overcurrent protection for multiwire branch circuits must be provided by a circuit breaker or fuse in each ungrounded conductor. The overcurrent protection device must be sized to protect the conductors against overload in short-circuit conditions. Consider an example of a multiwire branch circuit supplying lighting and receptacles in an office. The circuit consists of two hot conductors, each rated at 20 amps, and a shared neutral conductor. The voltage between the hot conductors is 208 volts, and the voltage from each hot conductor to neutral is 120 volts. Each hot conductor supplies a separate set of lighting fixtures and receptacles. To ensure compliance with the NEC, the following steps must be taken. Firstly, install a two-pole circuit breaker with a common trip mechanism to provide overcurrent protection for both hot conductors. Secondly, size the neutral conductor to carry the maximum unbalanced load. In this case, assume that each hot conductor is loaded to 16 amps, but not all loads are operating simultaneously. The maximum unbalanced load would be the difference between the current on the two hot conductors, which is 0 amps. Therefore, the neutral conductor must be sized to carry at least 0 amps. However, it's common practice to size the neutral conductor the same size as the hot conductors to provide additional capacity and reduce voltage drop. Thirdly, identify the neutral conductor by marking it with white or grey insulation. This helps to distinguish it from the hot conductors and ensures that it's properly connected to the neutral busbar in the panel board. Fourthly, ensure that all conductors are properly supported and secured in accordance with the NEC requirements. This helps to prevent damage to the conductors and ensures that the installation is safe and reliable. Fifthly, verify that all connections are tight and secure. Loose connections can cause overheating and potentially lead to fire. In addition to the technical aspects, it's also important to consider the safety implications of multi-wire branch circuits. These circuits can be dangerous if not installed and maintained properly. Always to energize the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow all applicable safety procedures and regulations. If you're not comfortable working on electrical circuits, it's best to hire a qualified electrician to do the work. Electricity can be dangerous, and it's not worth risking your safety or the safety of others. Proper training is essential for electricians working with multi-wire branch circuits. Electricians must be knowledgeable about the NEC requirements, proper installation techniques, and safety procedures. Training programs should cover topics such as circuit design, conductor sizing, overcurrent protection, grounding, and troubleshooting. Hands-on training is also important to allow electricians to practice their skills under the supervision of experienced instructors. Continuing education is also crucial to keep electricians up to date with the latest code changes and technological advancements. The electrical industry is constantly evolving, and it's important for electricians to stay informed to ensure that they are providing safe and reliable services. Furthermore, consider the implications of using arc fault circuit interrupters, or size and ground fault circuit interrupters, or GFCIs, in multi-wire branch circuits. SIs are designed to detect arc faults, which are a common cause of electrical fires. GFCIs are designed to protect against ground faults, which can cause electric shock. The NEC requires SIs in many areas of the home, including bedrooms, living rooms, and dining rooms. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoors. When using SIs or GFCIs in multi-wire branch circuits, it's important to ensure that they are compatible with the circuit configuration. Some SIs and GFCIs are designed for use with single-wire branch circuits only, while others are designed for use with multi-wire branch circuits. Using the wrong type of SI or GFCI can result in nuisance tripping or failure to protect against arc faults or ground faults. Another aspect to consider is voltage drop in multi-wire branch circuits. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slower, and equipment to malfunction. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop in multi-wire branch circuits, it's important to use the correct conductor size and to keep the circuit length as short as possible. You can also use parallel conductors to reduce the resistance of the circuit. When calculating voltage drop, it's important to consider the total current flowing through the circuit, including the current on all hot conductors and the neutral conductor. In commercial and industrial settings, multi-wire branch circuits are often used to supply 277-volt lighting. 277-volt lighting is more energy efficient than 120-volt lighting, and it can reduce the number of branch circuits required in a large building. When installing 277-volt multi-wire branch circuits, it's important to follow all applicable NEC requirements and to use appropriate safety precautions. 277 volts can be lethal, and it's essential to ensure that all circuits are properly grounded and protected. Also, be aware of the potential for harmonics in multi-wire branch circuits. Harmonics are distorted waveforms that can be generated by nonlinear loads such as electronic ballasts and variable frequency drives. Harmonics can cause overheating of conductors, transformers, and other equipment. In multi-wire branch circuits, harmonics can cause the neutral conductor to carry excessive current even if the load is balanced. To mitigate the effects of harmonics, it's important to use harmonic filters or to oversize the neutral conductor. The NEC provides guidelines for sizing the neutral conductor in circuits with harmonic loads. Pay close attention to the requirements for neutral disconnects in multi-wire branch circuits. The NEC generally prohibits the use of neutral disconnects in multi-wire branch circuits because disconnecting the neutral can create a dangerous imbalance in the circuit. However, there are some exceptions to this rule. For example, a neutral disconnect is permitted if it opens simultaneously with all ungrounded conductors. This ensures that the circuit is completely de-energized when the disconnect is opened. In summary, multi-wire branch circuits offer advantages in terms of efficiency and cost-effectiveness, but they also require careful attention to detail during installation and maintenance. Understanding the NEC requirements, using proper techniques, and following safety procedures are essential to ensure that these circuits operate safely and reliably. Proper training, adherence to codes, and a commitment to safety are crucial for electricians working with multi-wire branch circuits. By addressing common errors and staying informed about the latest industry practices, electricians can minimize the risk of accidents and ensure the integrity of electrical systems.